Okay, so I believe this topic is not a new one to you all. As for big boys and girls, you must have learnt about it already in um year 10 SS1. Okay, so you have an idea already of what an acid is, what a base is, okay, and what the generally do together. Okay, it is in acid base. It is from this topic that we can actually understand to an extent what goes on in the titration practicals you do in school, right? Because it has to do with acids and base. So that's one typical example. Okay, so today we'll be talking about what an acid is, what a base is, some types of acid, examples of acids, strong, weak acids, types of salts, if we are able to get to that extent, and so on. And also how to identify an acid or a base in a question or in a structure. Okay. Now we would be scrolling through or skipping some details. We won't be like typically reading through all these, okay, because I believe it's a topic you already know. Now, an acid, one of the definitions of an acid that we know is that it's a substance that will dissolve in water to give hydrogen ion as the only positive ion. Okay, so whenever a substance dissolves in water and it gives off hydrogen ion as the only positive ion, it is an acid. So we have these, for example. And base is typically the reverse of it. Okay, let's focus on acid first. Like we can see in this structure here, let me zoom in. We see HNO3, okay? When it's dissolved in water, the water makes it to now be in an ionic form, okay? And so we'll see the positive part and the negative part, okay? So that is what happened. This is neutral. But when it's dissolved in water, it now becomes a solution. It now becomes aqueous. When we are seeing in some balanced equation, I will see AQ. It means something that has been dissolved in a solute. So it has now formed a solution. Okay, it's no longer just a solid or a liquid. It's now a mixture of a solvent and a solute. So that's what aqueous solutions are. And aqueous solutions have the ability of forming ions. They are the only ones that can form ions. Neutral substances don't form ions. So how can this neutral HNO3 form an ion? It's by dissolving in a solvent like water. Okay, so what water does is to produce, is to make it ionic, and so we'll now have the positive side, the hydrogen, and the negative side, NO3. So these two, when they come together, they form a substance called an acid. The same thing for HCl, the same thing for H2SO4, and all the different acids that we have. So when we come this way, we see some common acids, right? Hydrochloric acid, tetraoxosulfate 6 acid, triosonitrate 6 acid, tetraoxochlorate. So these are some common acids, and they are regarded as inorganic acids. What are inorganic acids? Inorganic acids are typically acids that are not made of carbon, okay, that are not carboxylic acid, and they are typically acids that are not found in nature. Okay, they are usually synthesized. They are usually industrially or laboratory made. Okay, it's not like natural acid, which are the organic acid. Those are the acid that are the carboxylic acid we did in functional group in the last topic. Okay, now when we talk about organic acids, we can mention things like ethanoic acid, propanoic acid, butanoic acid. Those are organic, they are natural acids. Okay, then some other lactic and so on, based on their common names. Now, these ones are inorganic acids. Okay, and then we can see the formulas, what they are made of. Okay, and so these are it. Now, strong and weak acid. A strong acid will ionize completely in water, while weak acid don't ionize completely in water. Okay, so ethanoic acid is an example of a weak acid. Okay, and these other ones. So when we talk about strong acid, these three acids are the first and foremost: hydrochloric acid, H2SO4, and nitric acid. Okay, so these three are the major strong acid. Why are they strong acid? Because they will ionize completely. That means they will completely dissociate, okay, when they are dissolved in water to form our positive and negative ions. The positive ion there is the hydrogen, negative ion there is the anion. Okay, so for hydrochloric acid is the chlorine, for nitrate is the NO3, and for sulfate, tetrahydrosul sulfate is the SO4. Okay, but for weak acid, they don't ionize completely. Okay, only partially. Now, when we talk about what concentrated or dilute acids are, they are as concentrated acid is an acid that has, since we've been talking about acid, we've been focusing on the hydrogen ion, right? So that means hydrogen ion being formed is what makes a huge part of what makes something an acid. Okay, so a concentrated acid will be an acid that has much amount, that is totally acidic. Okay, and so it has a high amount of hydrogen ion in it, while a dilute acid is an acid that we have pouring so much of water inside, so it is now diluted, and so the acidity in it is less than in concentrated. Okay, it's just like saying um I diluted. Once you dilute anything in water, it's the water is making the amount of that thing um reduce, the concentration of that thing reduce. I hope you all understand what I'm trying to say. Okay, so why do we really need to dilute, or why do we need to know all this for us to be able to use acid, especially these ones that are here? Okay, but one of the qualities of properties of acid is that it is corrosive. Okay, that means it is not so um it's not so safe to handle in that nature. Okay, so they need to be diluted so that the acidity in it, the amount of hydrogen ion in it, okay, will not be too much to cause us damage, like burning of the skin and things like that. Okay, so that is why we need to dilute an acid so that it will be okay for us to use. Okay, so that being said, okay, we can see some examples of organic acids here. Okay, natural acids. We have acetic acids, what we see in vinegar, amino acid, protein. Okay, also amino acid is also natural. We also found it in living beings. You might have learned that in biology. Also, citric acid is the acid that is contained in lemon or lime. That is why lemons and limes are acidic fruits. But doesn't mean they are dangerous. These acids are not dangerous. Okay? So when we hear acid, not all of them has to be corrosive, dangerous to the skin and things like that. Okay, but they are sensitive. That is why people use things like lime to treat some of them. Some of them are sensitive to that extent to treat um pimple or things on the skin, right? Also fatty acid, formic acid, they are found in things like ants and bees and so on. So there are different kinds of acids that are found in these natural things that we consume every day, and they are safe, right? So So you can see from this question now, although this is a very old question, okay, milk contains what type of acid? Is lactic. So when we hear anything lactic, okay, is another way it's actually talking about milk. These are terms we can hear often in biology also. Okay. So that is it about acids. We said acids are substances that will dissolve in water, to give us a positive and a negative end, and usually hydrogen ion. Hydrogen ion will be the positive ion we'll get when we dissolve an acidic substance in water. Okay, so physical properties of an acid. One of the things we'll notice about acid, yes, I want to hear from you based on the few acids you have seen or maybe heard of. Okay, what are some of the things we can say are the physical properties of an acid? Yes, what do you know about an acid? When we talk about physical properties, they are the properties we can see, feel, touch. Yes, golden.
It is in liquid form.
Okay,
Uh,
that's very good attempt.
do you
Most
have a sour
acids,
taste?
very good. It has sour taste. Acid have sour taste. Okay, what other property do we have?
Conducts electricity in solution.
Very good. In solution. That is that is the essence of this all forming ion. Okay, so something that is in solution will form ion of positive, negative charge, and so it can now conduct electricity. So it also is corrosive, right? That is it's bond. That's why a concentrated acid, a new acid, when you buy it, you can't really handle it. And so when you are doing your titration, what would your teacher tell you? Well, you be careful when you are sucking in the acid. And that acid they are using for titration, it is dilute acid, because you can't even um that is laboratory acid. Now you can't go there and be putting your nose directly on it to smell it, because it also has a harsh smell, a choking smell. Okay, but that's not a general property, so that's why we will not include it as one of the physical properties. Okay, and so on, but the major ones are that it is has a sour taste, it is corrosive, it can conduct electricity when in solution, and also it turns blue litmus paper red. That is one of the most common way to show if something has acid content in it or not. So we can take a lime and we touch it with a blue litmus paper, it will turn red. But if we touch it with a red litmus paper, it doesn't turn blue. because that is not how it works. Turning blue from red is the quality of a base. So we'll get there. Now, chemical properties of acids. I saw this question in one of you, I think 2025 or 2024, like. Now, an acid carry out these three major reaction. So we're dealing with reactions of acid. These are the three major. One is reaction with metal, two reaction with base, and three reaction with triazole-carbonate. Now, you should note that whenever an acid reacts with metal, it will give you salt and hydrogen. Always hydrogen gas. Okay, so these are the two products we have to expect. Hydrogen gas must be there and a salt will be formed. Now, when an acid reacts with, so it mustn't be HCl, it can be H2SO4, HNO3, any of those acid will react with any metal. It mustn't be zinc, as you can see on the screen. Okay, it can be sodium, it can be magnesium, any metal you know. They will give you a salt and hydrogen gas. So how do you know the salts? Salts are usually made from the contribution of both the metal and the acid. The acid will contribute the negative side of it, not the hydrogen, the part that makes the negative side of acid, which is the chlorine, and then the metal. So these two things will come together to form our salt. The metal is the positive and the chlorine is the negative. So that's what forms our salt. Now then the hydrogen from the acid is what forms our hydrogen gas. Always ensure to balance your equation. And then the next equation or reaction of acid is that it reacts with a base. That's the simple one we know, and that's what we do in simple acid neutralization reaction. Okay, when acid reacts with base, it will always give us salt and water. Okay, and in the salt and water, okay, um positive side is donated by the base to form the salt, and the negative end is donated by the acid. So the sodium is from the base and the SO4 is from the acid. Then these things that makes this a base and the hydrogen that makes this an acid is what is coming together to form our water. Okay. Now reaction with triazole-carbonate. Now triazole-carbonate is also a kind of base. So it's acting as a base in this situation. And so that is why in the product we see salt and water also formed. I hope everyone can still see my screen because I'm viewing from my phone and I can't see it. Please give me a thumbs up if you can still see my screen. All right. So we can, that is reaction of acid and triazole-carbonate. Just that in the product for triazole-carbonate, we are not only getting salt and water, we're also getting another thing liberated, carbon dioxide, which is also a gas. Okay, so it's more like if you're doing a titration process and you get your salt and water, you notice some gas coming out that is milky in color. We know that it is what? Carbon dioxide. So these are the three reactions of acid. And I told you the other time that this is what tells you chemical properties of something. They're usually reactions, reaction with this, reaction with that, reaction with this. Okay, so we won't see chemical properties talking about it's having high melting boiling point, or it's corrosive, or those are physical properties. Okay, and then let's go to what acids can do. These are uses. You can read these things up. Okay. And then bases. I want us to attempt some past questions. That's why I'm just flowing through it. Bases are substances which we neutralize an acid to give us salt and water only. So any reaction where you see it's an acid and a base working together, okay, to give us, you see in the product, you see a salt, you see water in the product. That is what? Neutralization process. Okay. Now, how do you identify a base? How do you know that this thing is a base or this thing is an acid? Okay. This how do you know that this thing is a base? First thing, base gives off hydroxide ion when dissolved in water. Okay, a base would give us what? An hydroxide ion as the only negative ion when it is dissolved in water. For example, sodium hydroxide, when it is dissolved in water, we will get and the OH group. Okay, so it's just like acid, but this time around, um, acid is hydrogen ion that is being produced when it's dissolved in water, but base is the hydroxide ion. So mostly when we see a OH group, okay, in a compound, we can identify that compound and call it a base. But that is not the only way we can know a base, okay, because even ammonia is also a base, okay. Ammonia is also a base. So there are more than one scientist that have something to say about what an acid or a base is. Okay, this one that has to do with hydroxide ion is a common one that we know and you can detect easily for you and for your level. Ammonia is also a base because when it is aqueous, it also gives off um it is a proton acceptor. Okay, and bases are proton acceptor, so it will form H NH4, and then it reacts with water, NH4 and the OH group. Okay, so this is now the proton um acceptor we are talking about. So in the product it is accepting a proton. That is what makes ammonia also a base. Now we can see also another way to identify a base. It must also have an hydroxide group in it. Okay, mustn't have an hydroxide group in it. It can all just have an oxide. But when it is a metal attached to the oxide, that is when you know that it is a base. For example, sodium oxide. Sodium is a metal attached to oxygen, so it is a base. So what if we say something like what if we say something like copper oxide? Okay, what would this be? Will it be an acid or it will be a base? Someone should tell us.
A base.
Why is it a base?
because it is a metal.
Very good, because copper is a what? Copper is a metal. So when a metal is combined with oxygen, it is a base. Okay, but the reverse is the case for acid. When a non-metal is attached to oxygen, it is an acid. Okay, so when we have something like nitrogen oxide, sulfur oxide, carbon oxide, all of these are acids, acidic in nature, because nitrogen, sulfur, carbon are all non-metals. Okay, so the non-metal plus oxygen acid Metal plus oxygen, base. That's how you have to note it down. Now, properties of bases, the same thing in terms of corrosion only. So it's corrosive as well as acid, but it has a soapy feel, uh, bitter taste, and it turns red to blue, the opposite of what acids do. Now let's talk about pH. pH means potential of hydrogen. It tells us how acidic or how basic something is. Okay, so a pH scale, I believe you all already know this, is going from 0 to 7 to 14 rather. So the more acidic something is, the more it's going towards 0. The more basic something is, the more it's going towards 14. And 7 is neutral. So we have things like water. Okay, so um if something has a pH of 1, it means it's very acidic. If something has a pH of 4, this one that has pH of 1 is more acidic than this one of 4, because it's more like this, the more you're going here, the more acidic, right? But if something has a pH of 8, another has a pH of 10, this one that has of 10 is more basic than this one of 8. Okay. And then this one of 8 is very much less acidic. In fact, yes, very much less acidic. That's how we're going to put it. So that is the summary of what pH is. And there are different indicators that we have. I believe for us here, we majorly make use of methyl red, phenolphthalein, methyl orange, litmus, then maybe this bromothymol. Okay, these are the common ones. Okay, and they have this pH scale. What this means is that they are more effective in things that have, like at this pH point, okay, they start um having its color change. So that is to say, methyl red that has a pH range change from 4.2 to 6.3, it means it's more effective in acidic solution, okay, because it's acid that have this pH range. Now, things like phenolphthalein is more effective in basic solution. So these are things we can take note of, and also the what color they will change to. And then pH, um what is it called? pH graph. Okay. It has its own explanation as well. So for example, we have a graph like this. Okay. And in a pH graph, we have the volume of our the volume of the acid or the base against the pH scale. So let me just use this. So like this x y axis rather is usually talking about our pH range, and this bottom axis is maybe our base or our acid or whatever we are really considering. Okay, so if we have a an pH graph, are usually at the end of the day making an S shape. Okay, so for a strong and a strong acid and a strong base, we'll see the trend. Now this one at the beginning is for a strong acid and strong base. We can see the trend that the reaction will start slowly, okay, and then for some time it goes fast until it ends up in the equivalent point and goes just straight. Okay, so this can be used to explain why even in our titration process, it's not a fast process, right? Before our before titrant, before what we are trying to titrate, before we get our color change, it's a slow process. It's not something that you add in indicator and then you start um pouring pouring your acid or your base and it's already changing a color for you. That's not how it works. Okay, it's a slow and a continuous process. So that is why if when we see these graph, is more like looking like it is first stagnant at this point and then it can go on fast and then it's now stagnant again. You see it's making an S, somewhat S shape. So that is true for the rest of them. Okay, now if you see this one, you will see that the pH is starting from something like 3. Okay, and this one ends in something like 12. So we can say not so acidic, because 3 is not so acidic compared to when you're starting from 0 or 1, right? So that is why in this kind of graph it is a weak acid. Okay, because the more it's going towards 7, the more weak it is. And in this other example, the same thing, a weak base, because you see the end point when we trace it to the pH value, it is 10, below 10, like about 9. Okay, and so on. Okay, so let's attempt some past questions. Before then, if we see that we have more time, we can go into salts. Now, I forgot to say this. This is a um universal indicator. So universal indicator has color range. Okay, you know this um okay, this 1, 2, 3, 4, 5, 6, 7. I think is the colors we can get from white light and all these physics things, and also colors of the rainbow, I believe. So we can use this to actually know the colors that make our universal indicator, because you can also be asked questions from this. Okay, so I call it Roy Beef. You can have your own way of knowing it, but this tells you colors of the rainbow, tells you um different colors from white light, the physics aspect, and then also tells you these trends as well. So this is red going from number 1, and orange, yellow. So these two are more like another 2 shades of orange. Then we see yellow. This is our red, orange, yellow, and this green, which is the G, right? These are shades of green. So the more we are going further, the more dark the green tends to be. Even this also shade of green. Yeah, and then we have blue, shades of blue. And then we have violet. So in this case, we didn't have indigo. So you can just omit this from your rainbow color things. And then we have purple, which is also like violet. Okay, so we can use this to, the more, when we are using a universal indicator and we get a red color, we know red usually tells us acid, okay? Something changing to red usually tells us acid. Something changing to blue usually tells us base. The same thing is applicable to our litmus paper. So let's go to our question. Okay. Now, when we have this, the first question says, which of the graphs illustrates the variation of pH of a given volume of strong solution with the volume of strong base titrated against um titrated against it. Okay, so it's a strong base. Now we can obviously see based on what we have said so far that A is the answer because of the shape of the curve that we are getting. But aside that, I said this is the pH side of the scale. Okay, and this top will be 14 from 0 to 14, right? So we can see when we get to our equivalent point, which is this apex point, we can see it's ranging towards that 14. Okay, and this is not giving us it. And this is more like null. It's going to a different direction. And this is more like telling us is a very continuous um um fast process, which we know it is not in titration. So yeah, A is the option because it's first telling us it's actually a slow process. Then at some point it will go on, and then it will also be it's still a slow process. Okay, so that's what it tells us better than option I and IV. Um, Graph I and IV. Do you all understand?
Yes, ma.
All right. Now, the next question says, name two strong inorganic acids. So let me hear from you all. Two strong inorganic acids. Ah, nobody.
H2SO4, HNO3.
Very good. Uh-huh. That is it. Now the next question says calculate the volume of this mole dm cube of KOH. So this is a titration question. And when we see, it said, and when we see questions like this, mm, the formula for titration should be what should come to mind. Okay, so the major formula we use is C equals to N equals to CV. Okay, then when I was in school, I used to say this CV is curriculum vitae, what people used to apply for job. And so that was how this formula stuck to my brain. Okay, but you can do what works for you. And so in this kind of question, it said calculate the volume. You bring out all your parameters. We don't know volume. Okay, Say of this mole per dm cube. When you see mole per dm cube, what are they telling us there? Mole per dm cube is the unit for concentration, okay? Or mole per liter, or mole per centimeters cube. We know that they are giving us concentration, okay? So let us say this side is about of KOH. So this side is about KOH, the base. So the volume we don't know. The concentration they said is 0.1. What else? Required to neutralize 12.50 centimeters cube. When we see centimeters cube, we know this is the unit for volume. So they've given us volume. Okay. Of this mole per dm cube H2SO4. So that's the detail for H2SO4. Okay. The volume they said is 12.50. And the concentration also was given to us, which is 0.10. Now, if you notice, the units are contradicting. But then, since we're looking for volume, okay, and they didn't tell us our answer should be in dm cube or should be in this. Otherwise, naturally and normally, we are supposed to convert this our volume to be in decimeters cube so that everybody will be in uniform, since our concentration is also in decimeters cube. Okay, but except you're being asked to do that, or except you find out that, except you're being asked to do that, that is when you do that. But since in this case we see that our volume is, one of the volume is already in centimeters cube, okay, so we might just find our new volume also in centimeters cube. All right. Otherwise, it is natural for us to actually convert. Now, that being said, you should have conversion, this kind of conversion at the back of your mind. What centimeters cube is in decimeters cube or in liters. Okay, because I believe why don't give conversion table. There's nothing like booklet. So we should take note that 1 liters or is equals to 1 decimeters cube. And this also is equals to 1000 centimeters cube. So we can say 1 liters is equals to 1000 centimeters cube, and one decimeters cube is also equals to 1000 centimeters cube. So these are like conversion table you have to memorize in chemistry, because some of the time we need to do this conversion. But if we want our volume, our answer to be in decimeters cube, that is when we will now need to convert this volume of 12.5 to decimeters cube. But if we want our answer to just be in centimeters cube as well, we don't need to really convert. So we'll move on like that. And so our answer will now be in centimeters cube. So from here, what are we going to do next? The formula in terms of this, N is equals to CV. Okay, so there's also another formula you people can also, or you do usually use, since we are dealing with two substances, the acid and the base. Okay, so we're now more like saying there is N equals to CV. This is for acid, so we can say N acid, C acid, V acid over N base equals to C base acid, V base. This is the formula. Don't forget N and don't get rid of N. And another thing about this kind of questions is that you need a balanced equation, because that balanced equation, the reason why you need it is for you to be able to get your N. Very important, because we are not only looking for volume, We're also looking for N. N is number of moles. Okay, so if we are to fix into this equation, okay, we have our Na, we don't know. Ca, which is concentration of acid, we know it. Cv, volume of acid, we also know it. So we need to find Na and also Nb, so that we'll be able to find volume of base, which is Vb. I hope everybody is following me. So Na is equals to C times V of the same acid. So Na, N now is equals to Cv, right? So the number of mole of acid will now be equals to 12.50 times 0.1, which is equal to, let me use my calculator, 0.10 times. You people should be calculating and tell me the answer, please. What's the answer? Or you don't have calculator with you? Okay, the answer is 1.25. Okay, so since the answer is 1.25, that is for number of mole of acid, we still need to know number of mole of base so that we will be able to know what our volume of base is, which is what they actually asked us to calculate. How are we now going to know that of the base? Since NB, we can't get it from here because we're also missing volume. Two variables are unknown. We can't use only the concentration to find two unknowns, okay? And that is why we now resort to a balanced equation. A balanced equation, we know we are dealing with H2SO4 and KOH, acid base titration. So KOH plus H2SO4. We know that it's acid and base, and so we know that we will get to salt and water. So when we balance these two, first of our salt, okay, our salt to be composed of KSO4 plus H2O. Our process is not yet balanced, so we'd have to balance it. Now I want to leave that to you people. You people should balance it for us. This is completely written like this. K2SO4 based on oxidation state of SO4. So balance it and tell me which coefficient am I adding what to? Or is it balance? Write it in, balance it in your notebook, and then tell me if it is balanced. If it's not balanced, then tell me what I should add to make it balanced. This one is just like the skeletal equation, the substances that are used to get the product. So we need to balance it because it's that balancing that will help us to get our number of mole of acid. Yeah, very good. So what are we going to do to make it balance? Which number am I adding to where? If any of you, yeah,
Adding it to the KOH.
very good. Now K is now balanced. Is that all?
And
S,
also it's to the H2O.
very good. That is it. Christine, are you a girl or a boy?
I'm a go.
Interesting. All right. So now it is balanced. Now what this balanced equation tells us is the ratio of base to acid. Remember, this is the base and this is the acid. So it tells us that we need 2 KOH to get 1 acid because of the coefficient. The coefficient of KOH, which is the base, is 2. This 2, yeah, I wrote with black. And the coefficient of the acid is 1, which is, we don't really have to write 1. Okay, so the ratio of this is 2. So if we're reacting KOH with H2SO4, in essence, what this whole thing is telling us is that we need 2 moles of KOH to get 1 mole of H2SO4. So it's a 2:1 something. So now we are now going to relate this ratio to the number of mole of acid that we have gotten. So we can say based on the chemical equation, based on the equation, okay, 2 KOH gives us what? 1 H2SO4. That is to say, we require 2 amounts of KOH to get 1 H2SO4. So therefore, how many KOH? Because we are looking for the number of mole, NB, number of mole of KOH that we don't know. So how many KOH? So we are relating the coefficient of the equation to the number of moles so that we'll get the unknown number of mole. How many KOH will give us 1.25 H2SO4? So coefficient relating it with number of mole. So from here, what I like to do, okay, is to cross multiply. Or if you don't want to do that cross multiplying, because that one would never fail you. If you don't want to do that, you just use common sense. If 2 will give us 1, how many will give us 1.25? Okay, but if we cross multiply, this is what we will get. We will now say that is the initiation of maths in chemistry. We would now say these 2 will multiply this, and these will multiply this. And so we now have 2 times 1.25 equals to the NB, which is the unknown, times 1 is the same thing as unknown. So our number of mole of base will now be 2 times 1.25. So if you punch your calculator, you will get 2.5. So our number of mole of base is 2.5. We have finally gotten that. And that is what we need to be able to get our volume. Remember, our question says find volume. So you see the way we have been going to and fro is just for us to get that volume. So in essence, we'll first get the number of mole that we can get by direct multiplication, and then we relate it to the balanced equation to get the number of mole of the other substance, and then we'll now get the actual thing that the question asks us to find. So since we have gotten all the other apparatus, we'll now fix it into the equation. So when we fix it, Na is 1.25 divided by NB, which is 2.5, is equals to Ca, concentration of acid. Concentration of acid. Based on what you can see on the board, let me ask somebody. What? Golden. Golden, can you tell me what the concentration of acid is?
0.01. 0.1.
Very good, 0.1. Now, what is the volume of the acid?
12.5.
Very good. 12.5 divided by now concentration of base and volume of base. Who will I ask? Um, winner. Winner, what is the volume of the base? Is what we are looking for actually. Then the concentration of the base is 0.1. So times what we are actually looking for. So from here, you can first derive the formula if you want, or from here you can say 1.25 divided by 2.5 is equals to 0.1 times 0.1 times 12.5. It is 0.1 times 12.5, which is also 1.25, okay, divided by 0.1 volume of base. So from here we can cross multiply again, and it will now be 1.25 times 0.1. Okay, so this will give us 0.125 volume of base equal to 1.25 times 2.5, 3.125. Okay, divided by 0. So this is what we'll get. Then who can tell me what we'll do from here to get VB at this point that we have reached and we have paused? Winner, tell us. Based on mathematics, what do we do from here to make VB the subject of the formula? We are looking for volume of base. So what do we do from here to get our volume of base?
You've done this.
Divide both sides by 0.125.
Very good. Brilliant children. So our volume of base is equals to 3.125 divided by 0.125. And this will give us 25 centimeters cubed. Don't forget your units. Okay. But if they said let your answer be in decimeters cubed, you convert using this table here. Now the question number 3. All these many things was for question number 2. Um, we don't have much time again. You people did not join on time. So we'll just do 2 more questions and you ask your own questions. The question number 3, I hope you can see it. And the use of a universal indicator. Red color is an indication that a substance is, yes, concentrated acid, concentrated alkali. Alkali are bases that are soluble in water. So it's the same thing as saying base. It's like a type of base. Now, dilute acid, dilute base. So what's the answer? And tell me why your answer is the answer. Someone should tell us. I'm not the one writing why you're the one. So you should be the one attempting these questions. So I want to hear from you all.
Concentrated acid.
Very good. Okay, so why is it concentrated acid? Why is it not dilute acid? Why? Because every answer should have a why. If there is no reason for an answer, it means the answer was not well known. but it is you all are very you both are correct. Okay, because concentrated acid means an acid that has much amount of hydrogen ion, so it is very much as having acid content or acidic quality than a dilute one. A dilute one has been made kind of weak, so to say, by water because it has been diluted. So it is less very active. Okay, just like a medicine that you open and you leave to the air. People say it's not as it won't be as useful again as the one that has been in the tablet. Okay, so concentrated acid is the answer. Now the next question says, consider the following reaction. Silicon O2 oxide is acting as, okay, silicon 4 oxide is acting as what? Gas.
But what do you say?
Is what? Winner, what did you say?
What
Yes,
question
anyone,
do you
someone can
have?
answer. It is number 4. Silicon oxide in this equation now is acting as what?
I say what?
Number 4. I said silicon oxide is acting as what in the equation you can see on the screen. Yes.
An acidic oxide.
Good. Why is it acidic oxide?
It's reacting with a base.
Okay. And how do you know that it's a base? So when I was asking why is it an acidic oxide, I meant to ask how do you know it's an acidic oxide? How do you know? Like when you see silicon oxide, how do you know? How can you detect? Because also calcium is a oxide. The two of them are oxides. How do you now know that this one is an acid and the other one is a base?
One of them is non-metal and the other one is metal.
Very good. So silicon oxide is a what? A non-metal. Silicon is a non-metal. So we already know silicon is beneath oxygen in the, no, not silicon, that's sulfur. Silicon is a non-metal, so that is why. And calcium is very much metallic. So that's why it is now a base. Okay. So now the next question says, excuse me. The next question says, which of the following acid would form normal salt? Okay, we didn't talk about salts today. Which of the following household liquid will be effective in treating someone with too much acid in the stomach? So what do you think? A strong salt solution? I know some of you, when you are having um some of all these problems, you go and take salt in water, mix salt inside water and drink. Yes, I'm asking about question 6. Okay, how is it? Why do you say C? What is selling the answer to you there? Why is C motivating you?
because it's a base that will neutralize the acid.
Yeah, very good. It's a base. You can see the pH of the whole thing is 10, 10.5. The rest of them, the first one is 7, B is 4. So those are base, acid and neutral. Okay, so that's what happens in during indigestion process. That's what happens in some other processes where base would neutralize an acid. That's why when you have indigestion and go to buy a drug, what's on the drug? One of the drugs the people usually buy to treat indigestion is what? Mixed mag. And that is a basic content. If you look at the chemistry behind it, if you look at the formula that makes up that name, mixed mag, magnesia. Okay, it's basic in nature. And that is why indigestion that is caused by the over secretion of the acids, our natural acid in our stomach, it will now neutralize it and make us feel better. Which of the following gases? So please, if you have questions, you can our class. Calcium oxide. That's the common name for calcium oxide. And we know calcium is a metal. So calcium oxide will be a base. So that's why our answer would be D. Now we can see number 11 says an oxide has the following properties. It is white powder, it reacts with acid, it reacts with base, it is insoluble in water. This is an amphoteric oxide. Why? There are different types of oxide. We have basic oxide, alkalinic oxide, neutral oxide, amphoteric oxide. Okay. How do we know that this one is amphoteric oxide? Oxides that act as both acid and base. Now, alkaline oxide are basic oxide, are base oxide. Okay, that is metal oxides. They will not react with base again. Instead, they will react with acid because it's already an alkaline. Now, acidic oxides are oxides that um, are non-metallic, non-metallic oxide. So they are now acidic, and because of that, they will be reacting with base, not acid. Now, neutral oxide. Neutral oxide are neutral. Okay. And then example neutral oxide we have carbon monoxide, nitrogen oxide, NO, nitric oxide. Okay, those are neutral oxides. And then we have amphoteric oxide. Amphoteric oxide are oxides that act as both acid and base. So it can be an acid today, tomorrow it will be base. It's having the properties of both. It's behaving as both. So it can react with both acid and react with also base. So when we see in our options, we see the II said react with HCl, which is an acid, react with sodium OH, sodium hydroxide, which is the base. We know that it is behaving as the two, amphoteric. Please ask your questions because we have come to the end of today's class. Do you have all have any question? If you don't have a question, let me see a thumbs up. If you have a question, please unmute and ask. Okay, very good. I can see those that don't have a question. So, okay, since you don't have a question, I hope everyone learned something today. Did you learn something today? Okay, what's the answer of number 11? Amphoteric oxide. Amphoteric oxide, they are oxides that act as both acid and base. They are doing the two work. Like people that are both girl and boy. They are not in one place. They act as the two. All right. So I said, did you learn something today? I hope everyone learned something today. I want to hear your voices one after the other.
Yes, ma.
Yes, ma.
All right. Efosa, did you learn anything today? All
Yes, ma.
right. Melody. Melody. Okay, so today we have Efosa, we have Golden, we have Sharon, we have Christine, we have Melody, we have Winner.
Ma, Uyi is here with me, but his phone went
We
off, so he switched to
have,
mine.
okay, yes, I know someone that is not here was there. Uye,
Yes,
Uye Osa.
yes.
Is that all? Yeah, that's all. All right, have a good night rest. Bye bye.
Bye. Thank you, ma.
Bye. Hey, I forgot to tell what we are teaching tomorrow. I I don't even know what we are teaching next.
Too short
All
titration.
right, thank you. Titration. That's what is in this acid and base. And like, if I'm teaching you titration, is it like the experiment? Do you want to learn
Yes.
the experiment or the calculation?
The calculation.
Okay. We'll see how we'll give half an hour to it in the next class, and then we'll now teach the topic that we already have
Okay.
in store for the next class. So we'll
Okay.
just combine it to what we're supposed to learn. All right.
Yes, ma. Thank you, ma.
All right, thank you too. I hope Grace is not here for chemistry.